Right, now we turn to section 3 and begin a graphical analysis of the budget constraint. And this is, much of this is very straightforward. We're just looking at the equation of a straight line, but thinking about the economic interpretation. So we introduce that budget constraint, that looks like this. Expenditure looks in more generality like this one, where P1 and P2 could be different from 1. And so graphically, we think of the allowable or feasible bundles as being within the budget set. So this is the set of bundles that are feasible given income M, right? And then there's bundles out here that are not feasible. They're not affordable given prices and budget M. And then there are the points along the budget line where income is exhausted, where P1 times X1 plus P2 times X2 is exactly equal to M. So feasible, including exhausting the budget, and then infeasible. To recognize this or to analyze this, to use it, it's more familiar to put this in terms of this graph in slope-intercept form. So we rearrange this equation, right? We rearrange that to be in slope-intercept form. So we write x2 as a function of x1 given prices and income. That's just a straightforward little algebra problem, the usual way of doing that. And given that we've written this in that equation of a straight line, we should recognize the two components of this form. One is that m over p2 is the vertical intercept, and that minus p1 over p2 is the slope, right? Now, we're going to talk about the slope here in a second, but I want to introduce another extension and implication question. Here, notice here's a good example of how these in-class or extension and implication questions work. You're seeing exactly what you had in the notes, and I repeat the notes up till this point, and then I ask the question, what's the economic interpretation of the vertical intercept, m over p2, and of the horizontal intercept, m over p1? Straightforward question. Just give me the economic interpretation of those two quantities. And again, you should be, when we get to our in-class session, you should be ready to answer. I'm going to bring this question up. I'm going to call on somebody at random, and you should be ready with your question. Either you're ready with the question, or you say, I don't know, in which case it's, I go on to the next person. Most of these questions are straightforward. You should come up with your answer on your own time. To, stop the lecture if needed. Now, we are going to talk a little bit more about the slope here. So the slope has a definite, meaningful economic interpretation, and that simply is the effective rate at which the market, that is, the market prices, allows the consumer to substitute or trade one good for the other, in particular to trade good X2 for X1. In other words, it's the amount of X2 that one has to give up in order to get an additional unit of X1. And you could think of the rise over the run here, right? Draw a little triangle here, and you could think of rise over run. So another way to think about this is in the following little algebraic way of deriving that. You could think of what would happen if we took this budget line and we said, okay, this person's going to increase consumption of X1 by delta X1, And obviously, with fixed income M, they're going to decrease the consumption of X2 by delta X2, right? So we write that equation with that increase in X1, decrease in X2, and then write this equation for the original budget line. These are both on that. Both of these consumption bundles must be on that budget line, and we subtract, right? And we get that P1 times delta X1 plus P2 times delta X2 is equal to 0, or that these two things are equal. And you could rearrange those to get the slope of the budget line. Again, slope is rise over run. In this case, the rise is delta X2, the run is delta X1. And here, the slope, you could see it from slope-intercept form here, but you could also say, okay, yeah, what is that? It's delta x2 over delta x1 minus p1 over p2. The other thing that I want to say about this is to just give you a little exercise. Again, an extension and implication question. Here it is. And again, what have I done? I've just repeated what was in the notes. And I'm just asking this question. Suppose P1 is equal to 5 and P2 is equal to 10 without making reference to dollar amounts. What's the relative price of P1? Obviously, that's relative to P2, right? Straightforward in-class question. All right. Now we turn to section 4 and how the budget line changes with income and prices. And here all I've done is I'm just giving you a couple of exercises. I've given you a graph to work with. One thing right off the bat that I want to point to, because it matters later on, the graphing program that I work with, notice that 0 is the gray line, right? The 0 axes are the gray line, not the black line. So if you're going to, put a point at, I don't know, 0, 10, you put that point right there, right? Not down here, but right here, because that's 0. That matters later on. I just want you to make sure you see that. So here are the questions, and they're just in-class or extension and implication questions. It's just a couple of exercises. First of all, draw the budget line if P1 is equal to 5, P2 is equal to 10, and M is equal to 100. And, in terms of drawing that budget, when I call on you, what I'd expect you to do here is be able to tell me what the vertical and horizontal intercepts are, right? And tell me what the slope is, right? And once you've answered that question, I'm going to have an extension question involving changing income or changing a price. That's going to be an in-class question we'll actually do once we extend this question. So we'll discuss that in class. Let's see, let me flip forward. Here's one more in-class question that we'll talk about. How would this budget line change if prices and budget doubled? So that's the question I have for you. How would this budget line change if both prices and the budget doubled?